You may recall I said that all of these integrations pretty much come down to one of two things. Substitution, which of course we've now looked at a fair bit of, or by parts. So let's have a look at this idea of integration by parts. This is when we use it. So you're integrating the product of two functions, but one's not the derivative of the other. They're two completely different functions. I suppose you could think of it like a product rule for integration, because in fact it actually comes from the product rule, just rearranged. The way I tend to remember it's this way. Integral of u to v is uv minus integral of v to u. Let's go and prove that. So to say, it actually comes from our product rule. Write down the first diff the second plus write down the second diff the first. We know that to be true. So if I was to integrate both sides, well, the first part just becomes uv. Integrate the derivative, cancels each other out. Then I'm going to do the integral of each of the other two bits. Now, as much as I hate that notation because I've got the v's and the x's mixed, it's a formula, not an actual integration, so in this situation it's okay. But we can think of it like the dx's are cancelling, and we end up with the integral of u to v plus the integral of v to u. Rearranging that, we come up with the formula. How do we work out what to use for u, what to use for v? So u will tend to be something where the differentiation will make it a simpler function to work with. So that's the first thing I'm looking for. The dv, that needs to be something that can be integrated. So that's the two ideas I'm looking for when I'm looking at the function. So here's a typical sort of one, the integral of x times sine x. I've got two functions, neither is the derivative of the other. All right, so I said u would make the function simpler. Well, the two functions are x and sine x. Differentiate x, I get 1. That's certainly simpler. Differentiate sine x, I get cos x. Well, it's not really simpler. It's still a trig function. So it looks like I'll go for u equals x on this one. So u equals x, which means the u equals dx. dv, therefore, is the other function. Sine x, integrate sine, we get minus cos, which is uv minus the integral of v du. So uv minus x cos x, integral of v du becomes, well, it's minus becomes a plus. Integral of cos, now we just have the integral of cos to work out. Integrate cos, we get sine. I've just moved that to the front because it's positive, it looks nicer, I think. Log x, hang on, I said we use it when we've got two functions, one's not the derivative of the other. Well, there is another function there. The other function is simply the number 1. Choose u to be something that when we differentiate, we get something simpler. Well, if u is 1, differentiate 1, we get 0. Yeah, I suppose you could say 0 is simpler. But the key one for this one is dv needs to be something we can integrate. Well, dv is log x. Well, hang on, that's the question in the first place. So I'm not going to use that for dv. So that kind of forces my hand on this one. We'll have u is log x. Differentiate u, we get dx on x, which means dv is dx is x. So we get uv, x log x, minus the integral of dx. Integral of dx is, so we get x. And there's that x log x minus x that I've mentioned before. Now, if they say find the integral of log x, and that's all they say, I'm jumping straight to x log x minus x. If they say do it by parts, then okay, I'll use parts to do it. Let's do a definite integral. X e to the minus 7x. Okay, u's got to make the function simpler. Well, differentiate x, you get 1, that's certainly simpler. Dv, something I can integrate, well I can integrate both of those. So I'm going to go for u equals x. Du then is dx. Dv is e to the minus 7x. Integrate that, we get minus 1/7 e to the minus 7x. So uv, but now this is a definite integral. I need to put my limits there. So I'm going from 0 to 1. Minus becomes a plus. V to u. Now we have to integrate e to the minus 7x. Now it's up to you whether you want to substitute it for the first part now or just leave all the substitution into later. Well, that's up to you how you want to go. I'm going to leave it all to later for this one. So I'm integrating the 1/7 e to the minus 7x and I get minus 1 on 49 e to the minus 7x. Now I'll substitute in the 1, substitute in the 0, and there's my lovely looking answer. E to the x cos x. Now this one's interesting. Remember we said u is something that will make it simpler. Okay, if I choose e to the x, differentiate e to the x, you get e to the x. Well, that's not really simpler. Okay, choose cos x. Well, differentiate cos, I get minus sine again. Still a trig function, not really simpler. Okay, well, let's work with the dv. Dv is something that I can integrate. E to the x, well, yeah, I can integrate that pretty easily. Cos x, yeah, I can integrate that pretty easily. So it really doesn't matter what I choose here. I went with the e to the x for the u. So u is e to the x, du becomes e to the x dx, dv is cos x, v then becomes sin x. So we get uv, e to the x sin x, minus, oh dear, v du, e to the x sin x. Well, I've now got the same problem, because it's two functions multiplied together, neither is the derivative of the other. I've got to use parts again. But here's the thing, when you do it the second time, whatever decision you made in the first time, make the same decision. So I'm going to go for the exponential function again, because if I go for the trig function now, I'll go back to where I started from. So stick with whatever you went with. So u equals e to the x, du is e to the x dx, dv is sin x, v is minus cos x. All right, so we've got, but it'll be minus uv, minus minus becomes a plus, but this is where we're really got to be careful with the signs, haven't we? Because we're going minus v to u, but v is also minus, so we've got minus minus minus, which ends up minus the integral of e to, that was our original question. But this is now when we look at this and we don't think of it like working out, we think of it like an equation. So I'll get that integral of e to the x cos x and move it to the other side. So 2 lots of the integral e to the x cos x is e to the x sin x plus e to the x cos x. Divide by 2, we have our answer. Okay, 4f.